Hey guys, I'm going to be doing a problem for you guys from section 4.6, question number 16. It reads, growing sand pile. Sand falls from a conveyor belt at the rate of 10 meters cubed per minute onto the top of a conical pile. The height of the pile is always 3/8 of the base diameter. How fast are the A, height, and B, radius changing when the pile is 4 meters high? Give your answer in centimeters per minute. So, to help you guys better understand this, I drew a diagram. And we're given that dV dt equals 10 meters cubed per minute when it says that the sand falls from a conveyor belt at the rate of 10 meters cubed per minute onto the top of a conical pile. And height is always 3/8 of the base diameter. And here, so this is sand falling. And the volume of a cone is 1/3 pi r squared h. So with our knowledge, we can solve for r, and r is going to be b over 2. So b is going to equal 2r, and if you substitute in 2r for b in here, then you get h equals 3/8 times 2r, which simplifies to h equals 3r over 4. Now you can also solve that for r by multiplying both sides by 4 over 3, and you get r equals 4h over 3. So for part A, it asks us to find dh dt in centimeters per minute at h equals 4 meters. So basically, you want to take the volume equation and you want to set it where it's only where the only variables are v and h, because you're looking for dh dt. So you solve for r here, and r equals 4h over 3. So you substitute in 4h over 3 for r squared right here, and this is what you'll get. If you simplify that, it equals v equals 16 pi h cubed over 27. Now to take the derivative, you do dv dt, which equals 3, this constant just pulls through, and you just have to take the power, put it in front, and you subtract it by 1. So 3 is over here, the constant's just here, and h is to the power of 2. And you have to do it you have to add a dh dt because it's in terms of t. So then we know that dv dt equals 10, and if we substitute in 4 for h, you get 16 pi 4 squared over 9 dh dt. And you can solve for dh dt. If you put this in the calculator and divide both sides by this value, then you get 0.1119 meters per minute, which equals dh dt. But we have to put that in centimeter, so you just move the decimal place over to the right 2 places, and you get 11.19 centimeters per minute, which equals dh dt. Now for part B, it's basically the same process of part A, except you want to substitute in the h variable and not the r variable, because you're solving for dr dt. And so h is going to be 3r over 4. So you have v equals 1/3 pi r squared 3r over 4. And if you simplify that, you get v equals 1/4 pi r cubed. If you take the derivative of that, you get dv dt, and then you pull a 3 up front, so you get 3/4 pi, the constant is just going to pull through, and then you subtract 1, so r squared, and dr dt because it's in terms of t. And to find r, you take this equation. And because h equals 4, you put h, or 4, equals 3r over 4, and you solve for r, which equals 16 over 3. So you can substitute 16 over 3 in for r squared up here, and which gives you, and we know that 10 equals dv dt, so we can put 10 here and 3/4 pi, and then substitute in that value for r, so 16 over 3 squared dr dt. And if you divide this value to both sides, you get 0.1492 meters per minute, which equals dr dt. But remember, it has to be in centimeters, so you have to move the decimal place over 2 places to the right, so you get 14.92 centimeters per minute, which equals dr dt.
Alright, I'm doing 4.4 number 56 for the homework help problems. The problem reads, a rectangle is inscribed between the parabolas y equals 4x squared and y equals 30 minus x squared. What is the max area of such a rectangle, sorry. Alright, here's the graph that's given in the book. Y equals 4x squared is on the bottom, y equals 30 minus x squared is on top, and this is a rectangle that we're trying to find the max area for. Alright, so first we have to write the equation down for a rectangle, which is area equals base times height. And the height's going to equal the top parabola minus the bottom parabola, so it's going to be 30 minus x squared minus 4x squared, and that's going to be like right here. So then you get height equals 30 minus x squared minus 4x squared, which is 30 minus 5x squared simplified. Now the distance from here to here is going to be x. So if you multiply that by 2, it's going to be 2x. So the base is 2x. So then the area is just multiplying these two together. And then you get 60x minus 10x cubed equals the area of the rectangle. So then you have to take the derivative so you can find the max. So you get dA dt equals 60 minus 30x squared. And then you have to set that equal to 0 to find the critical points. So that is 0 equals 60 minus 30x squared. So then you have 30x squared equals 60, divide both sides by 30, you get x squared equals 2, take square root of both sides, you get x equals plus or minus the square root of 2. Now then you have to label your number line, so dA dt, and then your critical points are going to be negative square root of 2 and then positive square root of 2. So then you're going to have to plug in something greater than square root of 2, so I chose 5. And when you plug in 5 into dA dt, it's going to be negative. So they put a negative over there, and then I chose a value in between negative square root of 2 and square root of 2, which is 0. When you plug that in, it equals 60, so that's positive. And when you plug in something less than negative square root of 2, like negative 5, it's also going to be negative. So then the max is going to be at the critical point where it changes from positive to negative, and that's at square root of 2. So you know the max area is going to occur when x equals square root of 2. So then you just plug that back into the area formula. So then you do 30 minus 5 times the square root of 2 quantity squared times 2 square root of 2, and then 5 times the quantity squared, square root of 2 quantity squared is the same thing as 2, and then you do 30 minus 5 times 2, which is 30 minus 10, that's eventually going to equal 20, and then you do 20 times 2 square root of 2, which is 40 square root of 2, and that's going to be your max area. And then that should be answer choice E, and that is the correct answer.